Okay, we're going to try again. It looks like I'm still dropping about 70 frames, 70% of the frames. We'll see how it goes. Welcome to Made Up of Wires. We're decompiling Castlevania Symphony of the Night. If you like the low frame rate, you're probably from the 90s or 80s. You can go to sutton.z.dev to learn more, and we'll see how this goes. What we do is we look at machine code that comes from Symphony of the Night, either on the PlayStation or the PSP, typically. There are a few more versions of the game, but those are the ones we primarily look at, and see if we can write C code that matches or recompiles to that assembly exactly. And then if we can do that, we can rebuild the game and build our own source that we own the copyright to. We've been working on the clock tower and this flail guard flail, and working through register differences. A few minor things that we have to figure out, and hopefully we can get through it. So yesterday we had flail guard flail mostly done. This is the PlayStation version. Let's look at a few things here. We're on line 55. Let's see if we can figure out what's going on here. So there was this -2 that I had in here that did not need to be there, and I don't know why. Let me sync up the PlayStation version with the current PSP version. Make sure that everything's in sync. The PlayStation version is pretty close. We have a few things that we need to resolve. Line 90. Again, this -2 I don't think is there. So it seems like that was something hallucinated by M2C. I'm not sure where that came from. We have some ordering issues here. This should be unknown 2. There, fix that. And it looks like then the PlayStation version is probably correct. The only difference that we have currently is the GAPI call, which is going to be different. Instead of one symbol, it's a field access on a struct of a symbol that's earlier on. So let's put that back and see how close. That doesn't get us any closer really on the... So there was a fix, but it's no closer on the PSP. So we need to do two things. We have a stack size that's about 16 bits too large. We have two variables that appear to be using the same registers, which might not be the case. We can try replacing I with prim index. I'm a little nervous about doing that, but let's see how that goes. So we're going to start with, let's start with register S0. And what I want to see is, where does the use diverge between the two versions of the game? And so we're going to look at, and it's already coming somewhat into focus, maybe not quite though. So S0 is being used, I think, ephemerally. Ephemerally means it's used to construct the assembly language version of what that C code does, and wouldn't necessarily be there otherwise. We do have a bunch of cases where things are getting pulled from the stack that wouldn't normally be the case. So let's keep going and see. And I think that's just why S0 is being used, and then it's assigned to this variable, and it should be used that way for the remainder. I don't really like this -=1 construct here. And just to address the frame rate issues again, I think it's a upstream Cox issue. We've been having some issues. I thought switching to fiber last year was going to be panacea, but it's still Cox, I guess. All right, down on line 90, this is where the -2 came from before, and it doesn't appear like it's there anymore, but we can put that in. I still have my S0 registers highlighted. I don't. Let's get that back. So on 65, there's nothing really happening with that register again directly. So we don't control when it's an intermediate value like that. We don't really control what register gets chosen. Only when it's the target of a final assignment. Now 113. Something similar where possibly pulling this value out into a variable. And we could try doing that. We could call this prim index, and then even though it is an attack, this could be a different variable. Could be something else. And we could see if that is going to write this the same way, and it does. But it's not really doing the work that I'd want it to do. Let's try casting that as a sine 32 and see if we get the same thing. So we're moving it from S0 into V0 and then assigning the V0. Let's do one more variation on that. I don't think that this is going to be the same value, but you never know. So this is much closer. It is pulling in the S6 register in the process. But as long as it didn't break the other S0 registers, this might be slightly better. So I'm fine going with that. We do have a move to the S6 register, which isn't happening. And so I don't think that that's the way that's going to be written. So let's try to find something else. So we're still looking for S0 and how it's being used. Down here, this all looks fine. So I'm going to go with S0. Being fine. I'm going to try one thing. We have a Hey, don't fluff the pillows. Good to have you back. Sorry about the frame drops. Okay, so I think S0 is fine the way that it is. Let's go on to S1. And I think right now S1 is our S2. And we see some issues right away with that on 25. These are, yeah, just kind of, again, intermediate instructions that not much is actual variable assignment, so we can't trust it. It's just the value that got chosen. It isn't. Do we have any places where these are the same so far? No. So I thought it was parent. Let's look up here on line 15. So what we think is, I see. And S1 should be prim index, so line 25. So prim index is getting pushed to the stack. I'm going to go down and see if the I that's being used down here on 130, that looked like S1 as well. Let's change that. I did try this earlier. Let's change that to prim index and get rid of the I. That will help our stack space a little bit. And that looks like it was it. Just one alternate variable. So we have a difference here for GAPI. And then for this symbol as well, which is different between the two versions of the game. So what I want to see now, there was a -2 that was happening on the PlayStation version. And it's not happening on the PSP version. So let's go find that. And this is slightly different. So I think we do have a slight difference between these two versions of the game. We can look at this type as well, see what it is. So we have this as a S16 array. So one of two things is happening. Either this should be DE, in which case we would get the correct offset. If we can scroll this over, we'll see that this is a +4. Sorry, a -4. So this -2 should not be here. By DE, it'd be -4, so it would be D8. So let's go do that. Let's see if that array actually starts at D8. And how will we know? We won't. By D8, I mean DC. My guess is that's what's going on though. So we want to see whether or not the same type of data is occurring beforehand, 4 bytes earlier. And yeah, this definitely looks like it could be part of the same thing. So by DC, of course I meant EC. So I'm going to have to create a symbol here for EC. And maybe we should map this data. And that would make it a little easier to pull in. I'll make the symbol first, and then we'll do that. And we're just going to call it its address, because we don't have a specific name or use for it yet. But I think that's all that is. It'd be DUS, right? So I'm making that change manually. We won't get that symbol updated in the assembly, and there's no way to get it updated because GCC has baked in this address. We could actually tell, that's actually not the worst idea. We can set a size here, and we'll set the size to 4, 6, 8, 10, 12, 14, 16. Let's try that. So when we look at it again, we should get our EC. And what I would hope, but I'm not positive that this would happen. What I would expect to happen is for the source now, we would get the 1 EC. But we don't. We need a 1F0. I'd hope that we would get the 1 EC plus 4 there, but that's not what gets generated. I'm not sure why or how we can force that, but sometimes I feel like it does build the offset in. In this case, it didn't though. So we do have a symbol there now though. So we should be able to get this flail guard in. I'm going to go back over. I'm going to pull all these declarations in, both declarations in. And we'll see if this works. We do have a new entity extension, so before I do that, I'm going to put the entity extension in. I expected that to reduce the indent, but it didn't work, did it? All right, now we have to rebuild everything. And while we're doing that, let's look at some code reviews and see. Okay, some comments about build all. Still having some issues with the create entity. I think that linter is unrelated. Okay, phone call, let me. Oh no, it is my lint problem. Yuck, yuck. All right, this built. So now we can try to get this in. It didn't work. Let's see what might be the issue. So So we have an EC and it's going to F0. So I'm not sure why. Okay, this is strange, and I'm not sure what was happening in decomp.me. So it was the original symbol. We didn't need the -2. I'm not sure why, but we can get rid of this original symbol, or the symbol that we introduced. Rebuild this just to make sure everything's fine. I don't think there's gonna be any issues. And now what I want to do is import as much of this data as possible. So we need to see, where does this start? And it looks like 2160. And we have this entire section is for the flail guard. And we're gonna start taking this data and just moving it over piece by piece. I'm gonna rebuild with this new name. All right, and we'll open that data. All right, so our first type here is a 0.32. This column here is the data in little endian format. We don't want that. We want big endian format. 0.32, they are just 32-bit values. So we should be able to take them as they are. And we're going to make an array here. And dumb Vim columns. Can't paste correctly. That's close enough. And we're going to be taking pairs of these and putting them together as nested literal structs. So inside this array, these are each 0.32s, and the notation for nested structs is identical to the notation for nested arrays, which is different from most languages, most modern languages. Usually curly braces are for structs, and looking at this, this kind of looks like they are Konami fixed. Third time's a charm. Yeah, it did take 3 streams. We're still dropping all the frames, 120% of the frames. Let's see. All right, so we have this initial data in. I need one more thing here. I'm going to split this and just kind of incrementally import this data until it's all there. Splat will allow you to put multiple data sections. Last I checked, though, with the same name, last I checked, what happens is the last one gets written and overwrites the file for the other one. When linking happens, everything is correct, but it makes it hard to see. all the data in one place. My notation was wrong. Let's try that again. Forgot the equal sign. There we go. All right, now we're gonna keep going. It's easiest to go in order, even though sometimes I would like to just pick and choose. In general, I'd like to just pull things apart, and that's what's kind of nice about the Ship of Theseus style decomps like this. You can kind of work on pieces, but when you get to the data, really you kind of have to do it. You can come from both sides or one side or the other, but you do have to go through a pretty linear process. The next one is also bytes. Let's try to get that one in there as well. In this case, though, we want to grab the byte order ones because SPIM couldn't figure out what the type of this data was, and so it treated it as words, but we're treating it as bytes. And I think that's where I'll checkpoint it. So 21B4 is the next split. That'll work fine. And we keep going in. I might take this. Eventually what we have to do is figure out where this data is in on the PSP as well. So again, we have a set of bytes. In this case, the FF at the end is a terminator for a sequence of frames. So the remaining 3 bytes in there is going to be padding. And how much of this data do we have? These are going to be pairs. We can take the formatted version of those. We do have some negative numbers in here that probably would be worth working through. Give enough. Thought I had enough room, but not quite. Some things I can do in my head, some of them I can't. Like 0000. That's hex for 0. I can do that one in my head. Let's get these formatted, and then I'm gonna switch over so we're at 2 on E4. And the decimal ones, or sorry, the positive ones, many of them are pretty easy. This is 20. This is 28. We can make sure that this is working as we go. 15. All right, so for the rest of these, we the difference between the next highest bit position, so 10,000 hex, and this value is what the negative is going to be. So FFFA is going to be -6. You can also take the bytes, and if you have a calculator, you can negate them, or you can do a 2's complement if your calculator does that. And do I have 2's? I think it's the negate button. I was hoping that I had... Interesting, this has... This particular calculator has a... I think a little Indian 16. That's interesting. Oh, it'll take... yeah, it does have a little Indian. And you can do it with 8 or 16 bits. Interesting. Holder rash trace, definitely back at it again. Alright, what am I doing here? And every once in a while I just check. So when you start getting into double digits, that's when I start, my eyes glaze over and I can't think as well in hex. It looks like I'm doing pretty good getting most of these. EF, that's going to be -16, I think. Let's try it. No, is it -17? It's -17. All right, got those. This next set, SPIM, so they're 16-bit values. They're little endian 16-bit values. So SPIM thought they were words, so turned them into words of the same, converted the little endian words to a big endian 32-bit value. We don't need either of those things. So what I'm going to do is probably just do these manually. So I have to take the 4 hex digits and then swap the 2. So for a 0, that's easy. 18 for the second one. Or looks like 8. And write that out first, and then we'll do that one next. And it looks like I did the wrong one. I did the wrong one. That was one off. Not quite there yet. Okay, I jumped the gun a little bit. And do this one first. Yeah, I'm slightly concerned about our progress lately. I know I haven't been putting out as much as I had been previously. My velocity has slowed quite a bit. I don't remember if this was an array or not. It should be an array. 1E4. I think. We'll have to try that a few different ways. It may not work on the... Hey, Willie OD. Yeah, I do like a dark background on my terminal, and I'm fine with a light background in everything else. I think that's because that's mostly just the defaults, and I don't mind using the defaults. 2-1-E4. What am I doing? I feel like I'm mixed up. Got mixed up somewhere along the way. I feel like I'm not where I need to be. Yeah, what did I do? I see. I put all the data for 21C4 into 21C. That's right. So there is no 21C6. It's a lie. Now I understand. I confused myself, and we're back. We're back. We're so back. Possibly. 2-1-E4. Yeah, these are definitely 16-bit values. I'm not sure what is going on here. So the 2-1-F0, I'm going to keep these like they are and leave it as an exercise to somebody else in the future as to what I may or may not have screwed up. 2-1-F0 is our next starting point. Or we can try to figure it out. We may have to figure out when we get back to the PSP. Alright, so then just one more of these down below. I did make a linter to catch things like this. You can't have an extern and define it on the same line. And we can rewrite these in decimal as well. Oop, oop, oop. So we're done with all the data. We don't need the data coming from assembly anymore. And that works. So, yeah, and green terminal text. I'm not that old. Actually, I am that old. Our first, I'm pretty sure my first Apple II monitor was green on black. And it was amazing when we got a color monitor and we could display all 16 colors. I was also amazed when I learned that the Apple II emitted a composite signal. And so you could attach your Apple II to anything that would take composite input. And so really, they were selling these monitors. I'm sure they had a huge markup. But it was just a TV. So now we need to go find where this data is on the PSP. I think the easiest way to do that is going to be to look at flail guard and find a symbol over here. So some of these have been mapped. Should have at least one reference that has them. And hopefully this is partitioned with just the data we're looking for already, but we'll see. And hopefully it's the same. So this is looking a little different. The last 2%, the last 2% of what? We have a lot more to go than 2%. We do have a point. Was it this one? No. Both these are matching. We just don't always get, obviously, the decomp.me 100%. What am I looking for here? I need to see the flail guard for the US. Data. And does this look the same? It starts out the same and it ends the same. Somewhat strangely, these don't start in the same place. Interesting. All right, so we'll try to map this. Fortunately, both the PSP and PlayStation were correctly divided. So 26130 is the PSP version of this. So now we know that that is flail guard. And the hope is, if I move this over and use .e flail guard and move this over to the PlayStation version, Move this over to the PlayStation version. This will still work. And I don't think it's going to, but hey, we can dream. Yeah. And so we have something something slightly wrongish. Let's split those back. So what I'm going to do is kind of move each piece over individually and see if we can figure out where that difference is. This is a slightly more painful way to do it than I would hope, but it's what we got to do. So back here, I'm going to replace this symbol. Let's grab these declarations and we'll move them over. And it seems like it has to do with how this data is aligned and then the symbols that M2C picked. And I think we'll be able to get through it fine, but we'll see. So that looks like it should work and we're building fine. So we build these parallel directories for the PSP and the PlayStation. So we can work on them separately, but most of the time they're the same and we don't need to. Let's see if this works. And that worked fine. And then let's go grab Flail Guard as well. Flail Guard's going to have kind of the same where's the global data? That's entity room exit. I clicked the wrong button. So we'll have to update the symbols. So let's do that. Only the ones that are not named. And then I would assume, what am I doing? I would assume that we can bring the data in. The data should be the same. And then kind of move symbol names over. I think this will work. Any other D_USs? I don't see it. Right, so that worked fine. So we're gonna move over the data just like we did earlier. And then update the symbol names. What this? I guess we have a new name for it. And basically we're going to do the same thing. That's why it's not matching. So let's go grab it from here. And we're going to do the same thing, copy this entry, change one to .data, and then as we go through, update the assembly entry, just keep pushing it down. And what we can do along the way is update those symbols as we get the symbols pulled into C and all that data is being defined in C. Since it's static, we don't have to rely on the PSP or automatically generated symbol names anymore. Let me see what can I do to make this simpler. I don't need that anymore. Don't need that anymore. That might be helpful. I'll keep it open. I do need the US version. So along the way, we should also be checking to make sure that the data is the same, but I'm pretty sure that it is. So I'm not too concerned. I'll do a couple of these and then update the where the split is. So through the first animation, which is here. There actually is a second set of padding bytes, which is interesting. So we're actually through 26198. Padding is different between the two compilers. So we'll see more on one side than the other. And it's just good to know that it is padding. Undefined reference to 808. Included more data than I thought. Okay. So all we did was change symbol names between the two. So as long as all of this is working out fine, and we get all the data ported over, that should be fine. I think what's going to happen is we're going to run into some problems with how the data is defined. There's either a unused variable. No, I don't think that's the case. I'm just going to do the rest of these since they're all going fine. I will have to look at that one too, and oh, what did I do? I have one extra here. I think it's this one that doesn't exist, the second. Yeah. And let's go grab the end data as well. No, let's not do that yet. So the PSP, it does look like this cuts off at basically the same spot. I'm going to check this one more time. So FFFC008 is where we end. Okay, so there is, it looks like a slight difference here, and I'm not sure why yet, but we're going to grab this additional value here, and then we'll work out what's going on. I'm confusing myself, as always. Yeah, there's one additional value here. We'll grab that, and it's possible that it's a PSP specific value. But we'll see in a little bit. All right, now we just have that last array. I may have the type of that one wrong, the previous global, so we can go back and look at that as well. So that's the end of that data, and we should be able to get rid of this now. And that didn't work. Let's do this. Let's grab these values. It's much shorter. So there's something with how this data is split that's a little funny. So this is only the last 4 digits here, and we saw that there's that odd -2 that was happening. And so we're gonna have to work out what's causing this and how we can reconcile it. But we have all the data imported now, and that's fine. So let's update the symbols here. And what I want to do is get this so that the PSP version so we do have the -2 happening on the PSP version. So I do think that those are part of the same thing. So let's see if we can fix that first. So we're gonna do is take these 2 values and move them. We're gonna take that data out of this array, and we're gonna try to get rid of the -2 and see if this works. It doesn't. And we can't have the data there either. Okay, so let's try fixing it on PlayStation. So we're going to get rid of these two values on the PlayStation. We're going to add an additional value to the array above. And then then we're going to subtract 2 here and see if this works on both. And it does work on both. So yeah, just kind of an odd layout. Okay, so now I think that this makes both of these the same. Otherwise, we just have symbol differences. So let's take the PlayStation version and just replace everything in the PSP version. All the symbols are static, so we don't have to worry about them being shared elsewhere. And that works. Okay. So just odd layout things. Hey, Roaming. Good to have you. Fill in the missing frames with your imagination. All right. So now we can hopefully get rid of the PSP file. And we did. So we have matching flail guard. A little more work than I expected, but we got it done. Okay. I'll get that cleaned up and submitted later today. That's all the time I got. I'll talk to y'all later, and I guess I'm going to be calling the cable company. Adios.